This is the first in a series of videos about the free Havok SDKs. In the next few minutes, I'm just going to talk about how to get them and how to get started with them. So before we get started, there are a few prerequisites. You need to be running Windows, you need to have Visual C++ 2008 or 2010, and you need the Microsoft DirectX SDKs. And you can get the DirectX SDKs and Visual C++ Express both for free from Microsoft. So Havok is best known as a physics engine used in games, but it's actually a collection of 8 different products that do a variety of different things for games and simulations. And if you poke around the website in the products section, there's tons of information and videos about what those products are and what they do. But what you get with the free SDK is 2 products, physics and animation. So physics is a rigid body simulation. So in the world of physics, objects are solid and they can move around, but they can't change shape. And physics will simulate how they move, how they collide with each other, and it also gives you constraints and other types of forces that you can apply to them to affect the way that they behave. And so if you've used another physics engine before, either 2D or 3D, the concept should be pretty familiar. Animation provides skeletal animation for characters. So it does things like compress the animation, lets you blend different animations together or map animations from one skeleton to another. And it's not a skinning or a rendering package. It's just focused on the skeletal aspect of animation. So those are the 2 products that you get with the free SDK. And to grab that, you want to go to havok.com/tryhavok. You just fill out this little form here real quick, click the submit button, and you're onto the downloads page. And from the downloads page, you want to get the latest version of the SDKs for programmers. So right now the latest version is 2011.2, and there's two versions of that, one for Visual Studio 2010, one for 2008. And just grab whichever one corresponds to the version of Visual Studio that you're using. And I already have these downloaded, so I will just jump to that folder. And this is what you get in the download package. So there's no installer or anything, you just copy it straight to your system. And I'll go over what's in each of these folders. So the source folder has all of the headers that you want to include in your code. The lib folder has the binaries to link to. Docs has the user guide. Tools has the visual debugger, which I'll come back to later. And demo has a bunch of different demo applications that show different aspects of how the SDK works. And there's also a demo framework that comes with this that all the demos are written in. That makes it very easy to write simple programs that use Havok without having to worry about graphics or controls or any of those other details. So demos is definitely the place to get started, and you want to open this Visual Studio project right here, which I already have open. And there's just a couple of things that we have to do before we get started. So first, I want to change the build configuration to full debug multi-threaded DLL. Full debug generates non-optimized code, and it's just much easier to use in the debugger. So as you're getting started and experimenting, it's a good idea to use full debug because it'll make it much easier to troubleshoot if you run into a crash or an assertion. And the second thing that we need to do is tell Visual Studio where the DirectX SDKs are. So I already have that folder open. It's just in Program Files, DirectX SDK, lib, architecture. And I'm going to go to Demos, right-click on the Demos project, go to Properties. And in the linker section, click on Input. Click on General. And in the additional library directories, just tag that onto the end. And that will tell Visual Studio how to link to DirectX. And with that, we are ready to build. So I will build and run. Okay, and here is the demos. So when you first start up the demos, you get this menu that shows just a list of all the different demos that there are. You can navigate it with the arrow keys. And each of these bracketed menu items is a folder that you can dive into. So I'm going to press the right arrow key to jump into the physics demos, and you can just keep digging in, and I'll find one to run. So great, we're running the demo now. And there's some common functionality that's provided by the demo framework that you'll see in all of the different demos. So you can move the camera around by clicking and dragging with the mouse. You can also move around with the WASD keys, and you can go up and down with Q and Z. So it's a little bit like the controls to an FPS. You can pick up objects by putting the mouse over them, hold down the space key, and then drag the object around, and you can see that box is now following my mouse. until I let go of the space key to drop it. And you can see the light colored objects are dynamic, which means they can be moved around, whereas the darker gray object here is fixed in place. Another nice thing you can do is pause the simulation by pressing enter. So now I can still move the camera around and look at what's going on, but the simulation isn't being advanced forward. And I can also advance it one step at a time by pressing the space key, which is really nice for debugging. And while I'm paused, you can see this menu over in the top left corner shows a bunch of other things you can do. You can press the insert key to show the help text for the demo, which is useful because it just explains a little bit about what the demo is and any special controls that it might have. You can also press 3 while paused to restart the demo, so now we're back to the original state. And you can press 2 to quit back to the menus. So as you can see, there's a lot of different demos here, and we have them broken into a few different categories. So I'm pressing the left arrow key to navigate out of folders back to the top level menu. So here you can see physics and animation demos for each of those different products, and those are going to be the two most interesting places to look for demos as you're just getting started. And in physics, we have things broken down into a few different categories. So the API demos tend to show like a very specific aspect of the API, just one particular feature. Like the one we were just looking at just shows how friction works. There's another demo that will just show how restitution works. Whereas the use case demos will show more features working together to do something like what you might see in a game, like a character moving around or a bridge made out of different bodies constrained together in a certain way. And then the test demos do performance testing or kind of extreme cases that push the engine a little bit. And then there's a similar layout for the animation demos. So there's also some useful command line options, which I will set up now. So in the debugging section of the configuration properties, just go to command arguments to set the command line arguments for the tool. So -G will let you run a particular demo without having to go through the menu. So this is great for automation because it just jumps straight to the menu without needing any user input. And then -D will allow you to connect the demo to the visual debugger, which I'll show you in just a moment. So I'll run with those command line arguments. You can see this time we jumped straight to the friction demo, no menu. And now I'm going to connect the visual debugger. So I'm back in the root of the Havok package. I'm going to go into Tools, Visual Debugger, and run hkvisualdebugger.exe. And now you can see we have another view of the demo that's running in this window right here. And you can move these around independently. And when I move an object in the demo, it moves around in the visual debugger, but I can also grab objects in the visual debugger and you can see it moves around in the demo. So the physics worlds have been linked together and are being synchronized. And you also get a bunch of other information in the visual debugger. You can see we have some timer information. There's a bunch of viewers that will show you lots of different aspects of what's going on in the simulation. So it's a very powerful tool. There's a lot to it, and there'll be another video that covers more information about it. So with that, you should be ready to start experimenting with the demos, maybe tweaking the code, looking at the different features that Havok has to offer. If you need support, the first place to look should be the docs. So again, that's in the docs folder, and you want to look at the user guide. And you can also find support online at the Havok community forums on Intel's website.